Hello, here is a question on speed for Primary 6. Mr. Lee left town M and traveled towards town P at an average speed of 80 kilometers per hour. An hour later, Mr. Ong left town M and traveled towards town P at an average speed of 100 kilometers per hour. Mr. Ong passed town Q, which was halfway between town M and town P, 30 minutes earlier than Mr. Lee. If Mr. Ong reached town P at 10 p.m., at what time did Mr. Lee leave town M for town P? To help us solve the problem, it would be good to underline or highlight all the important facts given in the question. So we have 80 kilometers per hour, another average speed of 100 kilometers per hour, town Q halfway, 1 hour, 30 minutes, and 10 p.m. First, we need to establish the ratio between the average speed of Mr. Lee and Mr. Ong to find the constant time. So we have 80 kilometers per hour is to 100 kilometers per hour, and we have 4:5. It would be good if we could show this and all the relevant information in model drawing. So we have a line to show town M and town P, and town Q, which is halfway, M, P, Q. We also have Mr. Lee and Mr. Ong. The ratio of Mr. Lee's average speed to Mr. Ong's is 4:5. So we can draw this as well. So this would be 4 units, and 5 units for Mr. Ong. The portion here and here actually refer to 1 hour and half an hour. The portions are to show the longer time taken by Mr. Lee before he passed town Q. So another crucial clue is the extra time taken by Mr. Lee, which is 1 hour plus half an hour, and this gives us 1.5 hours. 1.5 hours is the extra time taken by Mr. Lee because he was traveling at a slower speed of 80 kilometers per hour. Looking back at the model, we can see that 1.5 hours is actually equal to 1 unit, because here we have 4 units, 1, 2, 3, 4, and here we have 5 units, 1, 2, 3, 4, 5. So the difference between Mr. Ong's 5 units and Mr. Lee's 4 units is 1 unit. And this 1 unit is actually 1 hour, this portion, plus half an hour, this portion. So we can write here 1 unit is actually 1.5 hours. We know that Mr. Lee's average speed is 80 kilometers per hour. So if he took 1.5 hours longer to pass town Q, we can actually find the distance traveled by Mr. Lee in that 1.5 hours. So we have one unit (80 times 1.5), and this would give us 120 kilometers. 120 kilometers is actually one unit here at Mr. Lee and one unit here at Mr. Ong's figure. Again, looking back at the model for Mr. Ong, we can see that from M to Q, there are 5 units. 1, 2, 3, 4, 5. And we know that Q is halfway M and P. That means we can actually find the number of units from M to P. That would be another 5 units. So the total number of units from M to P would be 5 plus 5, and that would give us 10 units. We know that 1 unit equals 120 kilometers, so 10 units would give us 10 times 120 kilometers equals 1,200 kilometers. So 1,200 kilometers would be from M to P. At the average speed of 100 kilometers per hour for Mr. Ong, we can find the time taken for Mr. Ong to reach town P. So the time taken would be 1,200 kilometers divided by Mr. Ong's average speed of 100 kilometers per hour, and we get 12 hours. So 12 hours is a time taken that Mr. Ong took to travel from M to P. Mr. Ong reached town P at 10 p.m. So we can draw another timeline here to show the information. This is M, this is P, and Mr. Ong reached town P at 10 p.m. If he had taken 12 hours to travel, we can calculate the time when he left town M. So if this is 12 hours, Mr. Ong left town M at 10 a.m. And we know that Mr. Ong left town M 1 hour after Mr. Lee. So again, we can compute the time that Mr. Lee left town M. So if this is 1 hour, this would be 10 minus 1, 9 a.m. So back to the question, at what time did Mr. Lee leave town M? This would be your answer. Mr. Lee left town M for town P at 9 a.m. Thank you.